So in this webinar, we will walk you through the configuration process for establishing Profinet communications with our SC2000 and SC3000 series cameras. So whether you are integrating with a PLC or setting up data exchange for machine vision applications, this webinar will help you to get up and running quickly and reliably. So let's get started with the system overview and setup steps. So here we will talk about the overview of the network architecture. So for the network architecture, you need to ensure that your laptop or IPC is on the same LAN as the camera and the PLC. So a common connection method is that all devices, including your IPC, are connected through a switch. Next, we will look at the 6 configurable modules of the camera. So the first modules we are talking about is the acquisition control modules. You can see from here. So this module is used to send control commands, for example, the trigger signals from the PLC to the camera. So these modules use the output address, the Q address here. And the next modules is the acquisition status modules, and this one is used to monitor the camera's acquisition status. And this module uses the input modules, input address, I address. And next, you will see there are 3 read result modules that support different sites. So this is used to receive the data from the camera. And you are able to switch to different sites. For example, it supports 128 bytes and 250 bytes and 64 bytes. And the last module is the user data module, and this one is used for a common string that's sent to camera. For example, if you want to switch a program or do triggering. So basically, these are all the modules involved when we need to build a Profinet connection. So next, from this page, we can see the function of each individual bit of these modules. So we will take a look at the definition of these input and output modules. So for example, we see here, we use the I2.0 and Q2.0. Of course, these addresses can be adjusted based on your actual PLC configuration. And in this webinar, we will start to set it to start from bed 2. So we can start with the first modules, which is acquisition status modules. And basically, this is a 1-byte status area that the camera used to report its current state back to the PLC. So each bit in this byte represents a different status flag. So the first bit is I2.0. So this is trigger ready, means the camera is ready to receive a trigger. And the next bit is trigger act, I2.1. And this one means the camera received the trigger signals. And the following bit is acquiring and decoding, means the camera is in the middle of capturing an image and is processing and decoding the images. And the next bit is result available, and this means the processed result is ready to be read from camera. And this one represents the timeout of reading results. And this bit is reserved and is not used currently, but may be used in the future. So we can skip this bit. And the last bit of this module is general fault. So general fault means there is a general error with the camera. So basically, in your PLC program, you can monitor this input bit to track exactly what the camera is doing or if anything goes wrong. So next one is the acquisition control module, and this module also occupies 1 byte and is used to control the camera from the PLC side. So each bit here lets the PLC send a command or signal to the camera. So we can look through each bit of this module, and the first bit is Q2.0 is trigger enable, means this bit have to be on to allow the camera to receive a trigger. And the next bit is trigger, so it's used to send the actual signal commands to take a picture or to run the solution once. And this bit is result act, means the acknowledge that the result has been received from the camera. And this one execute command to Q2.3 is used to send a command to the camera. So it's depending on the function setup. For example, if you need to switch a solution or to do the triggering. And this 3 bits is reserved and is not used currently, so we can skip this 3 bit. And the last bit of this acquisition control module is clear arrow. So it's used to reset any error that occurred on the camera side. So basically, the PLC write to this byte to tell the camera what to do. And next is the read result modules. And this one occupies 65 bytes in total. And the first byte represents the length of the read result. And the rest 64 bytes represent the real result data received from camera. So the last module is the user data module, and it is used when the PLC need to send some common data to the camera. And it also occupies 65 bytes in total. And the first byte, Q64, tells the camera how many bytes of the data are being sent. So that is the data length of the common string. And the rest 64 bytes here is the actual user data. So basically the command content that camera need to receive. For example, switch a solution or do triggering. So in short, the PLC writes in the number of bytes in Q64 and the actual command string in Q65 to 128. So next, let's look at the GSD files. As we all know, GSD file is necessary when we need to build the Profinet connection. So where you can find the GSD files. So actually, if you go to the download page of each camera model on our website, you will see there is a document called Industrial Protocol. And you download this document and unzip it, you will find the required GSD file inside the folder here. So now let's walk through the real configuration settings on the PLC side. Here we will take the Siemens S7 PLC as a reference. So you open the Siemens TIA software and you need to create a new project by filling in the project name and its path. And click the configuration device here. And you need to select the exactly same model you are using. So here we will use this model as a reference. And next step is you need to install the JSD file. So the JSD file is actually the one you downloaded from our website. And you just need to click install here. After you have installed the GSD files, you can see all the available models listed here. So you need to select the one you are using to connect with PLC and drag the camera here to connect with your PLC, like this. And if you double click this camera icon, you will see the available modules display here. And of course, you are able to modify the address of each modules. So here we will set the acquisition status and acquisition control modules to start at bed 2. And if you found that the modules here, display here, is inconsistent of the one display here, of course, you can right-click to delete and re-add the modules. For example, if you want to switch to 128 bytes or 250 bytes. So by default, it's a 64 bytes user data module. And next, you double-click this icon to set the IP address. So to set the IP address, you need to pay attention that the IP address here must not be same as the one on ICMVS. So here, the IP address should be different. Otherwise, there will be some unexpected behavior occurs. So after you have set the IP address correctly, you need to give a device name. So you can set the Profinet device name to match the name you set on ICMVS. So this is case insensitive, but you need to make sure they have the same characters. the device name has to be matched. So after you have gave the IP address and the device name, you can download the PLC program by selecting the PLC models here, display here. And you just need to click load to download the PLC program. And you need to click continuous without synchronization. And select stop all here and click load. And finally, you can click finish to successfully complete the download process. And after that, if you click go online, if you see all the check marks here have turned to green, means the connection is successful. So after you have made a successful connection, how you can monitor the camera communication in TIA software? So you need to create a new watch table. So on this left panel, you can right-click on watch and false tables to choose to add a new watch table. And this is where we will monitor the values of each bit. So you need to add variables to the tables. So in this new table, you can add addresses from different modules. So like the acquisition control modules, acquisition status modules, and read result modules. So for example, here, I2.0 to I2.7 is for acquisition status bits. And this Q2.0 and Q2.7 is for the acquisition control bits. And the rest are for read results. So if you have finished these steps, then you can see the live changes in real time as the camera and PLC communicate. So this setup helps you to debug the camera integration easily by watching the input and the output bits directly. So here, let's see how we can send the trigger signals to trigger the camera. So let's look at the configuration procedure on the camera side first. So we need to open the ICMVS software. And if you go into the communication settings, you can cite the device name and choose the result module size here. So this one, you need to make sure the device name need to match the name you used on PLC side. And this result module size, for example, if the result string to receive from camera is not over 64 bits, so you can just choose 64 directly. And make sure you have turned on the Profinet communication. And then you need to go to the camera settings to change the trigger source. The trigger source have to be the software trigger. And if you click run here, you can start the camera to wait for the trigger signals. So the orange stop button means that the camera is currently running and waiting for the trigger signals. So here, let's look at this flow chart to have a better idea like how the camera triggering communicates. So let's from the control area. So the first step is the PLC need to send a trigger enable Q2.0 signal to the camera. So after camera receiving the trigger enable signals, the camera will return a trigger ready. So this indicating that it's ready to receive a trigger signal. And once the PLC receive the trigger ready signals, and it will send a trigger signal to trigger the camera to run the solution once. So upon camera receiving the trigger signals, the camera will send back a trigger acknowledge signals, indicating that it has received the trigger and started executing the image capture process and run the solutions. So upon normal operations, the acquiring and decoding address will be set. So if you have also the result output is configured on your ICMVS software already, and the relevant result will be sent to the result data address. So after all the trigger is completed and all signals need to be reset. So to do that, the PLC should send Q2.2. to set this one to reset all the address. So here's a video to help you to visualize the procedures of the camera triggering. So first, we will go to the ICMVS and turn on the Profinet communications. And you need to make sure the device name is set accordingly, which is match the one you set on PLC side, and choose the result module. And you need to click Run to make sure the camera is in running status and waiting for the trigger signals. If you don't click Run and the PLC send a trigger signals, the camera will not receive it. So make sure this is on. Then we can back to the PLC side to see what we are going to do on the PLC. So first, PLC will set Q 2.0 to send the trigger enable signals to the camera. So you can also compare with the flowchart here. So we modify it to 1 to set it. And then you will see after receiving this, camera will set this I 2.0 and return a trigger ready signals. So it's indicating that camera is ready to receive a trigger signal. And then PLC will set Q 2.0, this one, to give a trigger signal to trigger the camera and run the solutions. Then you will see the camera will set I 2.1 that send back a trigger acknowledge signals and it indicating that it has received the triggers and started executing the image capture process and run the solutions. So under normal operations, the acquiring and the decoding address will be set accordingly. So let's see. So you will see the I 2.3 and I 2.4 are set. So if the result output is configured on ICMVS already, the relevant result will be sent to the result data modules here. So you see, you can receive the data from this result, read result modules. And after all the triggering is complete, PLC need to send the Q 2.2 to set this address to clear all the address. So you see the Q 2.2 is on and the camera PLC is keep triggering the camera to run the solutions. So this is a video to help you to visualize the procedures. So next, let's look at how we can switch the programs using Profinet communications. So you go to the ICMVS software and you open the project management and you select this communication triggering. You are able to define your own communication string. So here I want you to remember that the correct command format to switch a program is your communication string plus a space plus your program name. So how you can define your own communication string is here. So here we will define AH as the communication string and plus a space and this is your program name. And of course, you are able to rename your project to something easier to identify. So here, just to recap, the correct format is communication string plus a space plus program name. So for example, here we will use BH as a communication string and plus a space and plus 2, which is our program name. So for the PLC side, the first byte QB64 should be the total length of your common string. So in our case, BH plus space point 2 is 4. So we need to write 4 here in QB64, the first byte. And you need to give the common string in the user side data. So here, because BH plus base plus 2, we need to write these characters in each bit here. And after we have give the correct length of user data and your real common string, we can send execute comment signals. So we need to set this one, Q2.3 address. And this tells the camera to read the comment and switch the programs. So let's watch a video to have a better understanding how the switch program is working. So same as before, we go to the SCMVS software and click communication to make sure the Profinet communication is on. And we need to go to the project management to check the program name and define your own communication string. So in this case, for the program name 2, we'll use B to switch it. And for the another program named 1, we will use a communication string A to switch it. So we're back to the PLC settings. Let's see how it works. So because the total length of our common string is A plus space plus 1 or B plus space plus 2, so the total length is 3, so we need to write 3 here. And now we are going to switch to program named B. So we write in B plus base plus 2. And after we have assigned the correct data length and the common string, we need to execute comment. So here, we will set the Q2.3 to execute the comment. We modify it to 1. And you will see the camera have received the switch signals and the switch to project name 2 successfully. So this is a simple video to help you to visualize the whole procedure. So next, let's talk about some common problems you may face when you have a Profinet communication. So the first issue you may face is that when you log in the camera on SCMVS, you will find that the solution is blank, or you are not able to do any operations on the camera. So this is basically because the IP address you assigned on TS software is same as the one you set on SCMVS. So you need to give a different IP address, otherwise there will be some unexpected behavior occurs. So next page is unsuccessful switch program. So sometimes you are not able to switch programs successfully. So there are 2 potential causes. So the first one is you didn't give the correct comment length here in the first byte of this module. So for example, the communication string is set to 0 and your program name is 1. So the correct communication comment will be 0 space 1. So the comment character length will be 3. So you need to write in 3 here. So if you give a wrong comment length or you didn't even write in the data length here, you will not be able to switch the program successfully. So next, another potential causes is that the comment string formats are not filled in correctly. So like this. So you need to make sure the space here should be the type should be in type char. Like this, or this format. So you need to make sure you give the correct format of the space. And the next one, we are going to look at how you can get the flags of the switch programs. So you just need to focus on these 2 bits, I2.6 and I2.7. So I2.6, this bit will set to 1 if you switch the solution successfully, and the I2.7 will set to 1 if the switch program is failed. So you just need to monitor these 2 bits and its values to check whether you have switched the solution successful or not. So you need to pay attention that the firmware of the camera have to be V3 version or above. So if you have an old camera in your hand and the camera is running V2.0 firmware, you are not able to track the switch program status. So you always need to upgrade to the newest firmware to have this function on. So basically, that's everything for today's webinar. So we have covered the complete setup and the communication flow between the PLC and the camera. So thank you all for joining. So if you have any questions, feel free to leave the message and we can discuss here.